Question number 12. It reads, a conducting shell of radius r and charge q. There is electrostatic force between two parts of the shell which are on either side of a plane that is at a distance this from the center of the shell. So we need to find that electrostatic force, and the charge and radius of the shell is given to us. It's a conductance is going to be uniformly distributed. Now let's say this black colored is a sphere. This vertical line is showing a plane which is perpendicular to the screen. It is making this sphere into two parts. This one bigger one, another is this smaller one. Question says that this plane is at a small r distance from the center, which is of course lesser than capital R. Now we know this spherical shell, if it is charged, it's going to have an electrostatic pressure, and the electrostatic pressure is given by half epsilon naught E square. Now just inside the E is going to be 0, just outside the E is going to be kq upon r square. So this pressure is going to be is going to be acting only on the outer surface. Inside is not going to be there. So this pressure is going to create a force, and that force will be electrostatic force, and that's going to be identical in either of the two in magnitude terms and opposite in direction. So they are going to be equal and opposite basically. So force on either side of this plane is going to act on the spheres, of course, is that can be calculated by integrating PdA. Now then the force is a vector quantity, so we need to take care of the directions as well. Now if we draw the pressure is going to be on this curved surface of shell. It will have pressure direction is always perpendicular to the surface. Since it's symmetrical, you'll find the total force is going to be in the plus x direction. Now we can say the force is equal to pressure into area if we take the area which is perpendicular to the resultant force. So that projection area, you can call it, is going to be this area. So here we will find a circle, and we can use this circular area in order to get the total pressure force acting on this curved surface. Using this is going to avoid integration on this difficult three-dimensional surface. So resultant force is going to be in this direction, I'm just repeating. And if we can find area that is having perpendicular to this surface, that has the surface perpendicular to this direction and contains all these things, so this projection, this is called projection area, and you can use this projection area just to find the force. So we can say that resultant force in x direction is going to be equal to P into the projection area. Let's say radius of that circle is r dash, is a pi r dash square. Now we can substitute the value of P from here. So it's going to be half epsilon naught E square. E is this, which is q upon 4 pi epsilon naught r square. And area is going to be like pi r dash square. R dash can be calculated using Pythagoras. So this r dash square is going to be basically r square minus small r square. And then making a square is going to be like q square. And then you'll find 1 epsilon naught will get cancelled. 1 pi will get cancelled. 1 will survive because it's a square. So you will have a pi epsilon naught downside, q square upside. Numbers, it's going to be 4 square, that is 16 into 2, that is 32. Moreover, there's going to be r raised to power 4, and this is going to be r square minus r square. So that's going to be the force. We can further simplify r square, we can separate and divide on this. So it's going to be q square upon 32 pi epsilon naught r square within the bracket 1 minus small r square by capital R square. So we find that option D is exactly the same expression that we calculated. Hence option D has to be the correct response. This is how we can solve this problem. Thank you.